So here we have 5.4c, which is factoring special quadratic expressions. And the objective for that is to factor special quadratic expressions. So no surprise there with our goal for this video. So the big thing is to be able to identify these special quadratic expressions, one more than the other. The first one that we're going to look at is called the perfect square trinomial. Now, the perfect square trinomial, okay, so the perfect square trinomial, for that, truly you could just factor normally and then find out after you factor that it was a perfect square trinomial. You know, there are some things that you can look for. So if I have 9x squared minus 42x plus 49, one thing that I can look for is that my quadratic term is a perfect square. My linear term, not my linear term, excuse me, my constant is a perfect square as well. And then you can see whether the middle would work itself out, your linear term. But truly, like I said, you can just factor normally and then figure it out. The main reason why to know that it's a perfect square trinomial is that it can be used in references. For instance, you could say, you know, write a multiplication problem that would get you a perfect square trinomial. So that would be kind of the mainly knowing the vocabulary. Other than that, when you go to factor, you can factor normally. So I'm going to go ahead and do trial and error. So I'm going to start out with the 3x's for the 9x squared. For the 49, I know I could do 1 and 49 or 7 and 7. And so then I'll go ahead and do 7 and 7. Now because the 49 is positive and the 42x is negative, I know that both terms need to be negative. And then I can just double check 3x times negative 7 is negative 21x. Negative 7 times negative 7 times 3x is also a 21x, a negative 21x. And that gets me the negative 42x as my linear term, so I'm good to go. So what you'll notice is both of these binomials are the same exact thing. And that's what makes the 9x squared minus 42x plus 49 a perfect square trinomial, because technically I can write my answer as 3x minus 7 squared instead of 3x minus 7 times 3x minus 7. Now, I don't care whether you give me the answer as 3x minus 7 times 3x minus 7 or 3x minus 7 squared. Truly, it's the same thing, so to me it doesn't really matter. So again, it's just understanding that a perfect square trinomial, what happens when you factor them is that you get a binomial that if you multiply it by itself, you would end up getting that trinomial. So again, just that language and understanding the vocabulary, that's what's important. But other than that, you go about factoring it normally. Let's now talk about a difference of squares. So difference of squares. Now this one needs to be recognizable and you need to be able to identify it. So please note difference means subtract. Squares means a perfect square. Okay, so if I have x squared minus 64. So I have a difference because I have subtraction. And x squared is a perfect square. 64 is also a perfect square. Note, you do not have a linear term. So anytime you have a difference of squares, there will not be a linear term. Ever, 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 ever. Okay? So then what you would do is you'd set up your two binomials. One binomial will be adding, the other one will be subtracting. And so for my first term, I would take the square root of x squared, which is x. And for my last term, I take the square root of 64, which is 8. So I get 8 and 8. And then that is my final answer. I have found the difference of the two squares. You can always double check yourself by multiplying it out. And I'm going to show you, because some people are like, well, how do you know it's plus and minus? Well, let me show you the reason why, so that way you can understand it. So if I multiply the first, x times x, that is x squared. If I multiply x times negative 8, I get negative 8x. Then positive 8 times x is positive 8x. And then positive 8 times negative 8 is a negative 64. So if you notice, my linear terms eliminate, so all I'm left with is x squared minus 64. So that's the reason why anytime you factor a difference of squares, that's why you need to be able to recognize it, because one binomial will be adding and one will be subtracting. Doesn't matter which one is which, no, because truly, the terms within it are going to be identical. Okay, so let's look at, come on, next page. Let's look at another one. So I have 4a squared minus 49. So again, I'm looking, it's a difference because it's subtraction, so that is a difference. We need to make sure that they're both perfect squares. 4 and a squared are both perfect squares, so we're good to go on that term. And then the 49, also a perfect square, so we're good to go on that term. So I'm going to set up my two binomials, add, subtract, and then the square root of 4a squared is 2a, so that goes in my first for both. And then the square root of 49 is 7. And then I'm done. So I'm good to go. So, you wish that everything could be factored this way, but unfortunately, that's not always the case. So I have 16x squared minus 64. So this is a special kind of difference of squares because I'm looking at this and it is a difference, and they are both perfect squares, 16 and 64. However, okay, whenever you're factoring something, you have to factor it completely. For instance, if you end up with something like 2x minus 4, you technically need to factor out that 2 and get an x minus 2 on the inside in that quantity. So the big thing is anytime you're factoring, if you can ever factor out a GCF to start out with, you want to do that. And if you notice with 16 and 64, 16 can actually go into both of those values. And then you're left with x squared minus 4. So it is very important for any difference of squares, and really any kind of trinomial that you might factor too, is that if you ever spot a GCF, you need to factor out that GCF before you get started, because otherwise you wouldn't end up factoring completely, okay? And so then I'm going to set up my two binomials. Square root of x squared is x. Square root of 4 is 2. I have a plus, I've got a minus, and then I'm good to go. So that 16 that I took out is that is, part of it. It's almost like, remember when we factored out the GCF in the previous videos, that it was almost like that annoying little sibling that was just kind of hanging out, and that's what we need to also treat it as. It needs to hang out there. So other than that, we're good with factoring difference of squares. So you've seen the kinds of things that you will see. I do have one final problem, and it's more of a word problem. Okay, so I have this shaded area, and this should be a square, not a rectangle, but I just really did not draw it very well. So it's almost like the ACT. They are not, to size or whatever they like to say on the ACT when they can't draw it accurately. That's kind of what I'm doing right now. So those are basically two squares. One square has a 3a by 3a, and the other square has a 4 by 4. And so the directions will be to write the expression of the area of the shaded figure. And then the next piece will be to factor the expression that you wrote. Okay, so first let's go ahead and write the expression. So to find the area of just the shaded, I have to take the area of the outside square, which is 3a times 3a. And then I'm going to have to subtract what's been punched out, which is the 4 by 4 square. Okay, so then I have 3a times 3a, which is 9a squared, minus 4 times 4, which is 16. So that is the expression. So I wrote the expression. Now I need to factor that expression. So again, two binomials, because it is a difference of two perfect squares. 9a squared is perfect, and so is 16, and it's being subtracted. So the square root of 9a squared is 3a. Oh, and let me go ahead and do my plus minus. And then the square root of 16 is 4. So then I get 3a plus 4 and 3a minus 4 as factoring that expression. Now, the one time that you could be tricked, ladies, is if you have something like 9x squared plus 16. That is not a difference of squares. That is a sum of squares. Okay, so they might say factor this. Well, there's nothing to factor. They don't have a GCF. While they are perfect squares, it's not a difference of squares. So at this point, that is all that I could do. So that's something just to keep in mind for anything that you encounter, that it might look like it's a difference of squares, but actually it's not. Okay, and that actually finishes all parts of the video for this lesson. So there was just one video for you today.